All right, question 4 was our second question for integration by parts. I wanted something that verified that we understood when we were done doing integration by parts, and I'm glad I had it on here because there were a lot of students that stopped early. So I'm going to go ahead and not do the tabular method first. I'll do the tabular method after in case you want to see it, so that you can see where some students, where if you got like a 1 or 2 out of 4 on this, probably what happened. So just like the previous problem, we see two different function types multiplying together. And we definitely, in this case, we have no other possibility than integration by parts because we don't even have a composition of functions here. We have a basic square and a basic exponential. Like there's no inside function, right? To have u sub come save the day. So we have to do the same thing we did before. We're going to recognize that our u typically needs to be our algebraic piece. Go ahead and find du right now while I have my red pen. And then my dv in that integration by parts formula, the exponential, because it's not going to get worse when I take its antiderivative. All right, so there we are. So again, if we go and plug into that beautiful formula for the integration by parts that we went ahead and found by integrating the product rule, we end up with x squared e to the x minus, I could bring the 2 out in front if I'd like, x e to the x dx, right? So all that stuff, cute. Now here is where most students landed at a 1 out of 4, is because when they got here, they went, sweet, I'll just take the antiderivative of this. And for the most part, they took the antiderivative of each of the 2 factors in that integrand separately and went something like this, x squared over 2 times e to the x, which is absolutely not the jam, right? If that were the case, we would have done that in the first step as opposed to having to do integration by parts. So now that we're in integration by parts land, we go, oh, okay, we got to do it again. So here's the next step, right? I'll use purple and orange green this time. So again, I'm going to set my u equal to the algebraic bit. So my du is just dx. I'll go ahead and set my dv still equal to ev, because it's not e to the x, because it's not going to get worse. And then I can go ahead and I'll rewrite this whole thing with a beautiful equal sign and all my cute stuff. Now here's the deal. Everything we just did is inside of this integral symbol that had -2 multiplied by it. So I'm going to go ahead and when I write out my new integration by parts formula, I'm going to use some big parentheses or brackets just to make sure that I'm distributing that -2 to everything that's happening in that integration by parts. So we end up with x e to the x, that's my uv, minus the integral of e to the x dx. Okay. And now we're to something that we can actually evaluate the integral of, right, that indefinite. We can take the antiderivative of e to the x. That's the whole point. So we have one final step, minus 2x e to the x. A -2 times a negative is a +2 e to the x plus c. So a whole lot of y'all did not have this plus, or you did not have this 2. You forgot to distribute that 2 or that negative sign to that final term, and that's where you ended up with a 3 out of 4 instead of full points on this. Now, this does give us sort of maybe the tabular method would be really nice here, right? So, come on. In our tabular method, we basically just set up and say, okay, here's my x squared, here's my e to the x. If I recognize that I have to take derivatives successive times and antiderivative, if I have to do integration by parts more than once, I might as well just deal with all of it right away. So I know I'm going to have to take the derivative of x squared. I know I'm going to have to take the derivative of 2x. And then if I really want to, I could even say, well, what if I kept going and took the derivative of 2? Well, that's 0. And I know I'm going to have to take the antiderivative of e to the x a bunch of times. And then you have this oh, well, we need the u times the v, cool. And now we had a new u and a new v as we went down to the next line. So these are all the diagonals that we're going to need to add together. The first one is positive, then we subtract. Then since we're subtracting a negative again, this becomes positive. So our signs just changed. We saw this in class and sort of showed where this came from. But this made it a lot easier because then you're just going, oh, minus 2x e to the x plus 2 e to the x. And here you go, oh, stop, because that's a 0 times anything, which is 0. Add my c, and I'm done. So those were the two approaches to handle that last question on integration by parts. But I was really glad to see it on the, I wasn't glad to see the mistakes, but it made me feel like it was assessing something different than the first question, to see how many students got to that step, that second step in the U sub, and then from there just decided they could take an antiderivative, because that makes it really clear that we didn't understand the whole point of integration by parts is that when we have two things multiplied together, we only have these techniques, integration by parts or U sub. We cannot just take the antiderivatives of two factors and bring them down. Okay, there you go.